Okay, so we talked about finding missing sides of right triangles last time using Pythagorean theorem. That's like freshman stuff. Okay, today we're going to review what we talked about in actually secondary math 2, and that's using trigonometry. These trigonometric ratios, what we call them, to find missing sides of triangles. Okay, so 4 numbers, 1 through 4. What is it asking us to find? Read our directions. Find what? What's it asking us to do for numbers 1 through 4?
Find the value of each trig to that ratio.
Beautiful, I love it. Of each trig ratio. Okay, let's turn our papers over and remind ourselves, what in the heck is a trig ratio? Okay, because that's what we're going to use today to help us find some stuff. Okay, so I'm just going to go ahead and call them trig ratios. Okay, yes, our 3 trigonometric functions are sine, cosine, and tangent. Okay, and each one of these functions has its own ratio. Remember, ratio in math just means a fraction. Okay, so sine, its ratio, remember, is opposite over hypotenuse. Okay, you might remember these from last year. Next one, cosine. Its ratio is adjacent over hypotenuse. And tangent, its ratio is opposite over adjacent. Okay, remember that cute little phrase we used to remember these? So, ka, toa? Yep, that's what we're going to use today. So, ka, toa.
No.
Okay, that's literally a way to just memorize these ratios. Okay, so let's go ahead. Everybody have those down?
No.
So, ka, toa?
No, please.
Okay, Eli, are we good? Okay. All right, so turn your paper back over. So now that it's asking us to find the ratio, it's just asking us to find the fraction. So a couple things we got to do. Okay, so let's look at number 1 to start with. Okay, so it wants us to find the sine of angle x. The angle is always next to the function. So what angle are we standing at, you guys?
30.
What angle are we standing at?
X.
Okay, so we are standing at angle x. Okay?
So when it's asking that, it's just giving me the letter?
It's going to end up being a fraction, and I'll show you how. But yes, the letter is the angle you're standing at. Okay? So, based on where we're standing, we have 3 sides of this triangle we need to identify. We have the hypotenuse, which is always the hypotenuse. Which side is my hypotenuse?
Y to Z.
50. Okay, so that guy is always the hypotenuse. He's pretty easy to identify. Okay, now the 2 other sides we need to identify are the opposite side and the adjacent side. Don't overthink it. It literally means what they sound like. If I'm standing at X and I walk to the opposite side, so opposite is 40. If I'm standing at X, adjacent literally means next to. The side that is next to the angle that I'm standing at would be 30. Okay, so based on that, now we can find our trigonometric ratio, our trig ratio. So it wants sine, right? Sine, which means I'm going to use so. Okay, sine equals so. So the sine of x equals opposite over hypotenuse. Well, what numbers now are we going to plug in for opposite over hypotenuse?
40 and 50.
Beautiful, so opposite would be 40, right? Over hypotenuse, 50. Opposite over hypotenuse. And that is literally it. Final answer, 40 over 50.
That's it.
That is it. We're going to take it up a notch. We're just kind of reviewing where we get these trig ratios right now. Okay, but let's do a couple more. What angle for number 2 am I standing at? Good job. C. I'm standing at angle C. Okay, so the next step is based on where I'm standing at angle C, I need the opposite side, the adjacent side, and the hypotenuse. Okay, well, who can identify one or all of them, Braden?
Hypotenuse might be 40.
It is 40, always across from our right angle. Good job. So now if I'm standing at C, which side is my opposite and which side is my...
Or it would be the opposite.
Oh, which one, Bella?
The adjacent.
Good job. Right next to where I'm standing would be 24.
32 is the opposite.
Good. And then opposite from where I'm standing, 32. Great job. Okay, so again, it wants sine of angle C. So again, we are using so for sine. So now how we write that? Sine of angle C equals, again, opposite over hypotenuse. So what's it going to be this time? Opposite over hypotenuse.
32 over 40.
Good job. 32, my opposite, over 40, my hypotenuse. Oh. Okay,
Why did you say like sin instead of sign?
that's the abbreviation.
Oh,
Yeah, they always just use a three letter abbreviation.
oh,
Okay, so number 3, so instead of cosine, it just says cos, but that means cosine. What angle am I standing at for number 3? A, good job. Love that we can identify, that's super important. Okay, because based on where you're standing, it's gonna affect your sides. Okay, so if I'm standing at angle A, which side is my hypotenuse, adjacent, and opposite? Lily?
Your opposite is the 20,
Ooh, not quite. Hypotenuse is always across from the right angle.
25,
Good job.
and then, I don't know what it
Okay, that's okay.
Might be opposite.
15 is right next to where I'm standing, so that's gonna be adjacent. So then what's 20?
Opposite.
Opposite. So think if you walk to the opposite side, that's opposite. Okay, so this one's a little different than 1 and 2. We're not using sine anymore, we're using cosine. So this one was ka, remember? So ka, toa. So this one's gonna be cosine of A equals, this time it's adjacent over hypotenuse. So what is that ratio or that fraction going to be? Adjacent over hypotenuse. Lily?
is. 15 over 25.
Love it. 15 for my adjacent, 25 for my hypotenuse. And there we go. Okay, I'm actually going to change number 4 just so we can see the last function. So instead of sine of C, I'm actually going to change it to tangent of C.
Oh.
Okay, just so we can see that last one, how the last one's going to work. Okay, but again, what angle am I standing at?
C.
C. I'm standing at angle C. Very important. Okay, like I said, that will change your opposite and adjacent sides. Okay, so if I'm standing at C, where's my adjacent, opposite, and hypotenuse?
Opposite is 10.
Mm-hmm.
And adjacent is 24.
Good job.
And then hypotenuse 20.
Good job. Right, hypotenuse never changes. That's always the hypotenuse. But your adjacent and your opposite will change based on the angle you're standing at. Okay, so now that we know that, we want tangent, since I changed it from sine to tangent. Tangent is toa.
Sounds like
Okay, so how we write that? Tangent of angle C, or just tan C, equals opposite over adjacent. What's this ratio going to be?
24.
What was that? Sorry.
10 over 24.
Good job. Opposite 10 over 24. Opposite over adjacent. Boom. Great. Okay, so on your assignment, it'll give you a triangle, okay, with all 3 of the sides you know. You're going to have to identify where you're standing, and then given where you're standing, find that trigonometric ratio. So show me a fist to 5 on numbers 1 through 4. How you feeling on those guys? So, ka, toa.
I can find this better with drawing.
Okay, so let's go ahead. I actually want to go down to numbers 9 through 12 before we go to numbers 5 through 8. Okay, and based on time, we might skip a couple of them. Yeah, Bella.
I have a question. Not
Yes.
about this, but okay, wait. What's the SAT? Is that the same thing as?
We'll talk later because this is on my video.
Oh,
We'll
okay.
talk later. Okay, so quick answer, no it's not. All right. For numbers 9 through 12, what is it asking us to do here? Find what?
The missing side.
The missing side. Okay, wait a second. We know how to find the missing side of a right triangle. Weren't we using Pythagorean theorem on our starter? Yes. But here's the thing. For numbers 9 through 12, Pythagorean theorem is not going to work because look at your sides. Do you know 2 of the sides of this triangle? No. We only know one side and an angle. Ooh, okay. Okay, so here's what we're going to do for these. This is where we use our trig functions, our trig ratios, to find a missing side. When we can't use Pythagorean theorem, we got to use trig. Okay, so we're standing at angle 45 because it gives us 45. Based on where I'm standing at angle 45, what 2 sides is it giving me? Opposite, adjacent, hypotenuse? What 2 sides based on where I'm standing? Adjacent and?
Opposite.
Not quite.
Hypotenuse.
Good job. Hypotenuse. Okay. Okay. So now write these down for me because this is going to help us find. So we know that we're either going to have to use so, ka, or toa to help us find this missing side. Which one uses adjacent and hypotenuse?
So. No, wait.
So.
Can or sin, whatever.
Which one?
Whatever the C one is.
The C one, right? Cosine. Okay, I know since it gave me adjacent and hypotenuse, I got to use the one with adjacent and hypotenuse. So that's going to be cosine, right? Okay, so here's how we set it up. Cosine of the angle, cosine of 45, because it's 45 degrees, equals adjacent over hypotenuse. So what is that going to be?
11 over X.
Good job. Okay,
X.
now, here's the thing. We're like, wait a second. We're solving for x. Okay, now don't get intimidated by this cosine 45, guys. That is literally a button in your calculator. Don't let it scare you. Okay, but I do need to get x by itself. So look at the side with my x. X is on the bottom. I got to get it off the bottom. What's the opposite of divide by x?
Multiply.
Okay, we got to first thing get that thing off the bottom. Multiply it by x. Boom. That's going to move it to the other side. Okay, so let me rewrite this, and that's okay. We'll go into 11 space. We might just skip 11. 11 times cosine of x times cosine of 45 equals 11. Okay, that's what my new equation looks like. Now again, don't get intimidated here. If I want x to be by itself, now that it's on this side, what is the opposite of multiply by something? Divide. That's as easy as that. We're going to divide by cosine of 45. That gets rid of it, moves it to the other side. Cosine of 45. Now here's how easy it is, you guys. You're just going to punch this whole thing into your calculator. Okay, so definitely use one of mine because we have the nice little sine, cosine, and tangent buttons. Okay, so in my calculator, I'm going to put 11 divided by cosine of 45. So 11 divided by cosine button,
15, 5, 5, 5.
close parentheses. Yes, you are absolutely right. Let's practice rounding this baby. Okay, if I want it to 2 decimal places, let's just say. So 2 spots after my decimal. Got to look at the 3rd spot. Is this 6? Going to bump the 5 up or keep it a 5?
Bump it up. Or bump it up.
Bump it up, right? So now our answer is 15.56 for our final answer. Okay, and we'll go ahead and just get rid of 11. We won't care about that guy since we used his space. Okay, so we found the missing side of that right triangle, right? It was 15.56, but we couldn't use Pythagorean theorem this time. We didn't know what A or B or C are, okay? So let's go ahead and try that again for number 10. What angle am I standing at, or think what degrees? What degree am I looking at? Okay, so I know I'm standing there, right, at the angle it gives me. Based on where I'm standing, what two sides does it give me? Opposite, adjacent, hypotenuse? Look at you guys. Okay. So out of my three functions, sine, cosine, and tangent, which one uses opposite and hypotenuse? Lily? So, sine. Booyah. I know I'm going to have to use that guy. Okay, so we set it up the exact same way. Sine, and no, it is not sin, it is sine.
It's totally sin.
Sine of your angle, sine of 71, equals opposite over hypotenuse. So what am I going to write?
Oh, x over 13.
Love it.
But we can't have that. Or can
We can. I'll show you how to
As
solve
long
it.
as it's not on the bottom.
Yep, well, if it's on the bottom, you just have to move it first. This guy's actually a little nicer. He requires one less step because I'm looking at my side with my x. How do I get rid of divide by 13? I'm just going to multiply by 13 on both sides. And guess what? Now here's what I type into my calculator. Because x is going to be all by itself, I just got to type this baby into my calculator. Okay, so now I'm going to type in 13 times multiplied sine, your little sine button, of 71. Boom. We get our decimal.
12.29.
Beautiful. If I want it 2 decimal places, I look at the third. Is the 1 going to bump it up or keep it a 9?
Keep it a 9.
Keep it a 9. So, final answer, 12.29.
And 12 is the same thing as 10.
Yep. Actually, yeah. You'll use, the only thing different is that it's 75, and you'll multiply by 10
It's
on that
just
one.
the same like equation.
Same thing. Same exact thing. Nice, you guys. Okay, so show me a fist of 5 on that. Finding the missing side using trig. So, ka or toa. Ooh, I like it. Okay, let's go ahead and maybe do like 2 more examples. Now go back up to 5 and 8. These guys are similar but different. Okay, so look at numbers 9 and 10. I knew a side and an angle on numbers 5 through 8. Now what am I trying to find?
The degree.
Ooh, yeah. I'm not trying to find the missing side anymore. I'm trying to find
Yes.
the angle. But guess what? We're going to set it up the exact same way. Okay, here's where you're going to need one of my calculators. In fact, I'd love if you had one now so we can practice punching it in. So go grab one. Okay, so we know that the angle it gives us is where we're standing. We're now standing at the question mark, which again, we'll just call X because we like X. Bless you.
Ow.
Okay, so if I'm standing at X, the angle that it's telling me, what 2 sides does it give me this time?
45 and 12.
Uh-huh. Opposite, adjacent, hypotenuse?
Opposite and hypotenuse.
Opposite, I agree. Hypotenuse, we don't
So
have.
it's adjacent.
Good job. Okay. Now, out of our 3 functions again. So, ka or toa. And yes, if you write these down, it will be easy to see which one you need to use.
It's called a tangent.
Good job. I'm given opposite and adjacent, and the one that uses opposite and adjacent is tangent. Beautiful. We might use number 7 space too. That's totally fine.
Just put tangent.
Okay, so this is where it's a little different, you guys. Remember, the angle always goes with the function. So this time, it's tangent of x equals, what's my opposite over adjacent this time? 45 over 12, opposite over adjacent. Good job. Now, what in the world are we supposed to do here? I need x to be by itself. How in the heck do I take that tangent and move it away from the x? You don't know yet. On your calculator, it actually gives you the opposite of tangent, just like multiplication and division are opposites. The opposite of tangent, if you can see, is what we call inverse tangent. It's a little tangent with a little -1 right there. Okay, so what we need to do to get this x by itself, we just take the inverse tangent. That gets rid of it over here. Inverse tangent of that whole fraction is going to tell us what that angle is. Okay, looks really ugly and really complicated, but guys, all this now is punching it into a calculator. Okay, so now in my calculator, I need the inverse tangent, so you're going to click second tangent. Gives me my little inverse tangent. Then you just type in the ratio, 45 divided by 12, close parentheses. Enter. Ooh, how many degrees is this angle?
75.
Let's round it to 1 decimal place. What's it going to be with 1 decimal place?
75. 1.
Good job. The 6 is going to bump the 0 up to a 1. So we know that this x, this missing angle, is 75.1 degrees. Boom.
I don't like that.
That one's a little different because you got to use, right? We know that the opposite of addition is subtraction. We know multiplication and division. We even know square and square root. But like tangent and inverse tangent, weird stuff. Okay, so let's go ahead and try it again. Skip number 7. We used its space. So let's look at number 6. Okay, so I know I'm standing at the question mark. We'll go ahead and just call that guy x because we're going to find him. What 2 sides am I given based on where I'm standing?
Oh, what's this again? Tangent.
It's tangent, right? Because I'm given my opposite side and my adjacent side again, which if you weren't that fast at knowing it, that's totally fine. We know that out of my 3 functions, SO, CA, or TOA, or sine, cosine, and tangent, the one that uses opposite and adjacent is tangent.
Oh, that's nice.
Okay, so we set it up the exact same way, you guys. Tangent of your angle, this time it's x, equals opposite over adjacent. So what's that fraction, that ratio going to be?
It's going to be 75 or 75.
Oh,
No, 47. Crap.
47
I
over
read it
47.
Too fast.
These guys are the same. Ooh, let's see how that's going to affect our answer if that's the same. Okay, you guys. So there's one step, only one thing I have to do to get x by itself. So tell me, what is the opposite of tangent?
-1 tangent.
Sure, -1 tangent, called inverse tangent. It literally means the opposite
Call it
tangent.
-1 tangent. That's easier.
Good. Whatever's easiest. Okay, so we take the inverse tangent. Okay, that gets rid of it over there, which means we have to do the same thing over here. We're going to take the inverse tangent of that fraction.
45 degrees.
Ooh.
It's very beautiful.
Okay, so let's go ahead and punch that into our calculator, see if Eli's right. So again, when you're taking the inverse, you got to click second, then tangent, then your ratio, 47 over 47, or 47 divided by 47. Oh, look at that. No decimals needed. We know that that missing angle is 45
That'd be cool if you
degrees.
did 180 degrees. That'd be pretty cool.
That would be cool. Alrighty.